Hello friends, welcome back. In this session we will start Docker, because Docker is in today's industry, it is widely used. Almost all the organizations are using Docker. In every application development, Docker is used, and that is a very powerful tool to create the uh, virtual machine. So we will learn Docker thoroughly. The entire course of Docker we will learn here. So just keep watching our sessions regularly and keep supporting us. Okay, so let's get started with Docker. First we will see the introduction. So what is Docker? If I say, so Docker is a tool that create virtual machine. Yeah, a virtual machine we can create using VMware also, or we can use hypervisor in our system to create the virtual machine also. But there is some limitation with the hypervisor or VMware. If we use those tools or those softwares to create our virtual machine, there are some limitations. So to remove those limitations, Docker is come in the picture. So so Docker is a tool that create the virtual machine called container in Docker. So first thing, the virtual machine is called container in Docker. We will see what is virtual machine, why it is called Docker. We will see all that. So just for the definition purpose, if someone will ask you in interview, or if you are working in an organization, then if they might ask, you know Docker, so can you explain what is Docker, how it works? So you must have the entire picture in your mind, why Docker is came in picture, what is the requirement for Docker, and what exactly Docker can do, what are the features of Docker, what are the limitations of other tools if we don't use Docker. Okay, so just for the definition purpose, you keep this in mind. Docker is a tool that create virtual machine called container in Docker, and it does OS, yani operating system level virtualization. Docker is a tool that is used to create the virtual machine, but virtual machine called container in Docker. So we can say that Docker is a tool that is used to create the container. We will see, we will define what is container, or we also will define what is virtual machine. Some is little bit difference is there which between virtual machine and container, but purpose is same. Okay, so Docker is a tool that is used to create the container, and it does the OS level virtualization. OS means operating system level virtualization. Docker use a Docker engine. That is, Docker engine is nothing but Docker only. You can say, see, if I say Java, then what is Java? That is JRE only. You can say that also, no? Java is nothing but JRE or JDK, you can say. JRE will be always used to run the program, but JDK is used to develop the program. Using JDK you can develop the program and run the program, but using JRE you can only run the program. So same thing, Docker is nothing but Docker has Docker engine only. So what we have to do, we need to install Docker engine only. If I say install Docker, it means you have to install Docker engine, or sometime some developers say that Docker daemon also. Daemon is what? If you say in Java, what is daemon thread? The threads who supports the other thread, or you can say that the thread, the JVM threads who start the JVM, manage JVM, that is a daemon threads. daemon threads will automatically started, like garbage collector. Garbage collector is what in Java? A daemon thread, because that thread is automatically doing the memory allocation and deallocation, memory deallocation if it is not required automatically. So that is nothing but that is helping JVM or helping your application. That is a daemon thread. Okay, in the same way you also can say docker daemon. Docker daemon means who run the docker, simply who create the container, something like that. So that is a docker, or you can say docker engine also. So same, if you say docker engine or docker daemon, both are same. So docker has a docker engine, or docker is nothing but docker engine only. You can say like has, or you can say docker is nothing but docker engine only, or docker daemon, that is used to create OS level virtualization, to create, or you can say make, that is used to make OS level virtualization. Okay, now here 2-3 points, 2-3 words or terms that might come in your mind. What is virtualization, what is container, what is virtual machine, what are all those? Operating system, what is operating system? You definitely know. Operating system is what? That and program that is installed on your hardware, that is called operating system. Like your computer Linux operating system. Currently in our operating system we have installed Ubuntu, so Ubuntu is our operating system. In your computer that might be installed Linux, or Window 10, 11, whatever version you are using, that is operating system. Windows is operating system, Ubuntu is an operating system, Mac is an operating system. And in Linux there are so many other distributors like CentOS, Fedora, so many are there, so many distributors are there, Mint is there, so all are operating systems. So, and what that is called operating system, the application that is installed directly on your hardware, called operating system, that will use your hardware, that is called operating system, you can see. Okay, if you don't know operating system, then also don't worry, we will in the upcoming sessions we will create one separate course for operating system. Don't need to worry, but just currently you understand your computer or your desktop or your laptop, Windows is an operating system, or whatever the operating system you install, like you might use Ubuntu, Mac, whatever, so that is operating system. Okay, so we will see what is virtualization, what is container, and what is VM. The difference between, because VM is nothing but, virtual machine is nothing but container only, but in Docker we say container. Okay, so let's revise this introduction again. A Docker is a tool that is used to create the container, and it does OS or operating system level virtualization. Docker is nothing but Docker engine only, that is used to create OS level virtualization or operating system level virtualization. Okay, now first we will see what is virtualization. What is virtualization? You might hear in your organization, we have added one virtual machine. So what do you think, what is virtual machine? Where is that virtual machine? Something that you can't see, that is, you can say that is a virtual, but that is not the actual definition of virtual in this context. So virtualization is what? Virtualization enables the hardware resources of a single computer to be divided into multiple virtual computer, called virtual machine. Suppose in my system 16 GB RAM is there, 1 TB hard disk is there. Currently I have installed only one operating system in my computer, but I want to install 4 operating system. I want to treat my system as a 4 computer. How it is possible? Total 60 GB RAM is there. I can divide that in 4 slot, 4 GB, 4 GB, 4 GB, 4 times, and I can install I can dedicate that 4 GB to a particular operating system. In another MB, like 1 TB hard disk is there, so 250 GB hard disk I will allocate for a particular operating system. 250 for particular operating system. Like that I can divide in 4 slots. So that is nothing but resource or single computer is divided into, or that is nothing but the resource sharing only. Okay, so virtualization enable the hardware resources. What virtualization do? Virtualization enable the hardware resource. What is hardware resource here? Hardware resource is your computer hardware, like your computer CPU, computer RAM, computer hard disk, all the computer resources, all your laptop or desktop hardware, that is called hardware resource. So virtualization enable the hardware resource of a single computer to be divided into multiple virtual computer called VMs. So you just understand, you have a 16 GB RAM, 4 GB you have separated, 4 like you have divided 4 in 4 slots, each have 4 GB RAM, and you want to install 4 operating system in your laptop now or in your desktop. You want to install 4 operating system. In that case you can do that also, no? So that is nothing but virtualization. In that case you have a 4 virtual machine. And another definition you can say, virtualization is a software that make computer environment independent or physical infrastructure, while cloud computing is a service that delivers shared computing resources, software, and are on demand via internet. Suppose you might have used Amazon Web Services, AWS. In AWS EC2 instance you are launching, no? You are purchasing one EC2 instance. So how it is done? You are telling your requirement. I want this GB of RAM, I want this GB RAM, this GB hard disk, this much memory I need. In that case, and after selecting all the security, SSL certificate, everything, you are launching that instance. So that will be creating one one operating system and one complete system they will give you, a dedicated computer they will give you. But is it really one computer or it's a virtual machine? You don't know. They might have used some virtualization tool, and using that tool they can divide their RAM and they have created one virtual machine, and that virtual machine they will give you, and you have to pay something for that one, some amount you have to pay. So that is virtualization. Virtualization is, or you can say it is a software that make computing environment independent of a physical infrastructure, while cloud computing is a service delivered shared computer resources. While cloud computing is a service that delivers shared computing resources, software and data on demand via internet. Yeah, that is what your AWS is returning, Amazon Web Services is doing. Okay, so that is virtualization. So simply you just understand, in your Amazon you are launching EC2 instance, so that is nothing but a virtual machine only. So from this diagram you are can better understanding what is virtualization. Suppose this is your machine, downside whatever this downside this diagram you will see. So it is representing your machine. Machine is means machine hardware, that include RAM, CPU, hard disk, etc. Anything whatever is installed in your system, all are resources. So that is your machine. Suppose for example you have a 60 GB of RAM, it is written here 60 GB RAM and 1 TB hard disk. Your computer has, or your laptop has, your laptop hardware has 60 GB RAM and 1 TB hard disk. Now you thinking, I want to divide this RAM and I want to divide this hard disk into 4 slots so that I can install 4 operating system. And if I install 4 operating system, it means I have 4 computer, and that computers you can access. So that is how you are doing. You are taking the help of hypervisor. You just here you understand, hypervisor is nothing but it is a software tool that does hardware level hardware level virtualization. Simple. So you, on top of this hypervisor, so this hypervisor called type 1 hypervisor, I have written in this brackets type 1. What is the meaning of type 1 hypervisor? Type 1 installed, where it is installed on your machine hardware. Machine hardware has a 60 GB RAM and 1 TB hard disk. On top of this hardware directly you have installed one hypervisor. You have not installed any operating system. You understand here, you have not installed any operating system on your hardware. You have installed hypervisor, type 1 hypervisor on your machine hardware directly, and using this hypervisor you did virtualization. See, you can see virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4. 4 operating system you have installed, and now this 4 operating system or this 4 virtual machine, you can see this is a one virtual machine, this is virtual machine 2, virtual machine 3, virtual machine 4. Each virtual machine has its own hardware and operating system. And if you see here in this first virtual machine 1 has 4 GB RAM and 250 GB hard disk. And in the same sequence, if you see the virtual machine 2, that also has a 4 GB RAM and 250 GB hard disk. Virtual machine 3 also has 4 GB RAM, 250 GB hard disk, and virtual machine 4 also has 4 GB of RAM and 250 GB hard disk. And from where this 4 GB RAM and hard disk is taken? It is taken from your machine hardware. If you see, your machine has 16 GB RAM only. 16 GB RAM. So 16 GB RAM. So 4 GB, 4 GB, 4 GB. You can divide in 4 parts. Okay, and 1 TB hard disk means 250 GB per machine you can give. You can divide these resources among all the hardware. So this is nothing but virtualization, and here you have used hypervisor 1, hypervisor type 1. This is the one example of a virtualization you can understand from here. From this diagram now you can clearly understand what is virtualization. This is virtualization example 1. We will take another example also. So now you understand, virtualization is nothing but creating a virtual machine on a hardware using some virtualization tool. Here we are using hypervisor, or so many other virtualization tools are available. You can go on internet and you can search how many tools are available for virtualization. You can go through that one, but that is not the purpose of this course here. Okay, so next one is, we will see another example of virtualization. You can see here this one. From this diagram you can understand this is virtualization 2. Here what you are doing, so this downside, if you see again, this is your machine. This is your machine that has a 16 GB RAM and 1 TB hard disk again. But here steps is different. In the first example you have installed hypervisor directly on your hardware, but in this one we are not installing hypervisor on our computer hardware. What we are doing, we are installing one operating system, any operating system, whatever you want to wish, Linux, Mac, Windows, whatever it is there. But Mac generally will be installed on Apple only, it will become inbuilt only. But yeah, definitely that is the example also. Suppose you have bought an Apple laptop, and in that one Mac is already installed. On top of that one Mac you can install hypervisor too. So same way here on our machine we have installed one operating system. That can be a Linux operating system, Windows operating system, Mac operating system, any of them. Linux is nothing but a kernel. Linux has some distributor like Ubuntu, Fedora, Mint, so many are there. Okay, so that are the distributor. So on our machine hardware we have installed one operating system, and on our operating system we have installed hypervisor. Suppose I have one hardware that has a 62 GB of RAM and 1 TB hard disk, and on top of on my computer hardware I have installed Linux operating system like Ubuntu. Like Ubuntu I have installed. On Ubuntu I have installed hypervisor type 2. In our operating system we have installed hypervisor, that is type of hypervisor 2. So this is called hypervisor type 1, that is directly installed on your hardware. But that hypervisor that is installed on your operating system called hypervisor 2 type 2. Okay, and again this process is same. This hypervisor, what this hypervisor do? This hypervisor will help you to create a virtualization. See, again, virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4. Simple. So here is one tool. Here one tool we are using to create virtual machine. Here one tool is there that we are using to make virtualization. That is what is that? That is hypervisor. Here also, if you see in example 1, we are using hypervisor to create a virtual machines. Virtual machine is nothing but a computer only, you can see. Okay, computer means that has a hardware, that has an operating system. Simple. If you see from your computer perspective, what is there in your computer? In your computer, some hardware is there like camera, RAM, hard disk, CPU. So that all are the hardwares only. And one more thing your laptop has, that is what? That is operating system. So operating system plus hardware is called computers only, simple. So this is called a machine only. So you can say machine, virtual machine. This is nothing but a computer only. Okay. So in virtualization 1 or virtualization 2 example, one tool is there that is called hypervisor, that is used to create the virtualization. So what is hypervisor? We will see now. What is hypervisor? A hypervisor is a software that create and run virtual machine. Yes, exactly same what it is happening on this diagram. Either you see the example 1 or example 2. Same. Hypervisor is creating virtual machine. So a hypervisor is a software that create and run virtual machine. A hypervisor sometimes called virtual machine monitor. Yeah, simple. It is monitoring, no? Hypervisor is monitoring. What it is monitoring? What your hypervisor is monitoring? It is monitoring how much RAM each virtual machine has, how much hard disk each virtual machine has, when this system will be up, when this will be shut down. All it is managed by hypervisor. If you starting some of the machine, then definitely that request has to go first to hypervisor, and then hypervisor will start that machine. It will manage that machine. Every request, whatever the response request is going to this virtual machine, go on through hypervisor directly. Okay, so that's why it is saying hypervisor is a software that create and run virtual machine, and hypervisor sometimes called virtual machine monitor. Isolate the hypervisor operating system and resource. So what it is do? It is isolate the hypervisor operating system and resource from virtual machine and enable the creation and managing of those virtual machines. So it is create and manage the virtual machine. Simple. Hypervisor is used to create the virtual machine or used to create the virtualization. You can say in the very simple context, you can say hypervisor is used to create virtualization. And what is virtualization? Create dividing your hardware among the computers. That's it. Okay, so that is called hypervisor. Now types of hypervisor. Here we have seen two types of hypervisor, type 1 and type 2. Definitely. So there are two different types of hypervisor that can be used for virtualization, type 1 and type 2 hypervisor. So what is type 1? What is type 1? A type 1 hypervisor, also referred as native or bare metal hypervisor. Why? Because it is directly installed on hardware, that's why it is a native. Okay, and run directly on the host hardware. You can see directly, see this is the same point. A type 1 hypervisor is also referred to as a native or bare metal hypervisor, run directly on the host hardware to manage the guest operating system. See, if you see the virtualization example 1, your hypervisor is directly installed on your hardware, that's called type 1. So this is type 1 hypervisor that refer to a native or bare metal hypervisor and run directly on host hardware to manage the guest operating system. Okay, it take the place of host operating system and VM resource and schedule directly the hardware by hypervisor. It takes the place of host operating system. Host operating system is what? See, if you see in virtualization 2, so here if you see how many operating system is installed in this virtualization example 2, 1, 2, 3, 4 and 5 operating system. Virtual machines are 4. Virtual machine are 4, but operating systems are 5. You can see each virtual machine has its own operating system and one operating system, that is a base operating system, you can see. Okay, so that's why. So but type 1 don't have any. If you see type 1 has only 4 operating system, because this hypervisor type 1 is acting like as host operating system, and virtual resources are scheduled directly to the hardware by hypervisor. Okay, this type of hypervisor is most common in the enterprise data center or other server based environment. So KVM, Microsoft Hyper-V and VMware vSphere are the example of type 1 hypervisor. These are the type of or example of type 1 hypervisor. Microsoft Hyper-V, KVM. So KVM, Microsoft Hyper-V and VMware vSphere are example of type 1 hypervisor. KVM was merged into Linux kernel in 2007. So if you are using modern version of Linux, you already has access of KVM. Okay, that is different thing. Like if you have a Linux latest, so in 2007 it is already coming, your Linux is coming with KVM. Okay, that is different. Next one is a type 2. What is type 2? If you see, type 2 is installed on your operating system, your host operating system, you can see. Type 2 hypervisor is also known as the hosted hypervisor, and it run on conventional operating system as a software layered application. So first it is running always on operating system because it is installed on operating system. Okay, same. This hypervisor 2 is installed on operating system. Okay, and it works by abstracting guest operating system from the host operating system. So it is acting like hosting between host operating system and virtual operating system. It is indicating for both. It is interacting with both. Okay, it works abstracting guest operating system from host operating system. Virtual machine resources are scheduled against a host operating system. Virtual machine resources are scheduled against host operating system, which is then executed against the hardware. Okay, a type 2 hypervisor is better for individual user who wants to run multiple operating system in a personal computer. Suppose in your laptop or in your desktop or whatever you have, if you want to install more than one operating system, then how can you do that one? Using hypervisor 2. Very easy. Okay, so VMware workstation and Oracle VirtualBox are example of hypervisor 2. So you can use VMware workstation and Oracle VirtualBox also you can use. This is a hypervisor 2. Okay, and if you wanted to use hypervisor 1, then you can use KVM, Microsoft HB and VMware Sphere. Okay, fine. So this is if you want to read more about hypervisor and virtualization, so you can go through this link. This is a Red Hat official page actually. Okay, I will add this link in the description also, you can directly go through. Okay, next one is, what is the limitation of hardware level virtualization? If you see here, this is nothing but virtualization only. We are doing virtualization. What is the limitation of this virtualization? What is the limitation? Suppose, so you see that very one major limitation that is seen here, that is what? Resource wastage. See how? Suppose if you see this virtual machine 1 has to do a task of 5 GB RAM. How can you do that one? No, you can't do. Definitely you can't do. Because this virtual machine 1 has only 4 GB RAM, but it wants to run, this virtual machine 1 wants to run a software that is of 8 GB or more than 5 GB, like 5 GB, 6 GB, 7 GB RAM needed for that application. But in that case, this virtual machine can't do that one. Why? Since you have 16 GB, you can see hardware is 16 GB, complete 16 GB. So definitely if you want to run any application of 5 GB RAM, that is taking 5 GB RAM, definitely it should run, no? But it is not running. You can't run because your virtual machine has only 4 GB of RAM. Has only 4 GB of RAM. Since your hardware is a 16 GB, but you created 4 virtual machine and each virtual machine has 4 GB RAM. In that case, you can't run any application who is having more than 4 GB RAM access. Even if other virtual machines are not up, even the other virtual machines are not up, they are stopped, they are not working. In that case, RAM is free, but still you are not able to run. Why? Because virtual machine has only 4 GB of RAM. It is a dedicated RAM. You can't use more than this one. You can use less. Yeah, 3 GB application you can run, but for 5 GB application you can't run because you only have 4 GB. You are restricting, you are dividing exactly, like permanently you are assigning this RAM. Whether you use, whether you don't use, that will be remaining same for this virtual machine. This is the one limitation. Resource is wastage. Resource is wasting. Okay, so this is, and you can see 250 GB only storage is given, but I want to store some other data, then you can't do that one. But since you have 1 TB RAM, 1 TB hard disk, what you can do? So this is one virtualization in this hardware level virtualization. This is the major limitation that is coming. We are wasting our resources by permanently assigning to virtual machines. Okay, even it is a virtualization 2 or virtualization 1, it doesn't matter. Here also you can see virtual machine has a 4 GB of RAM only, but if you want to run any application that needs more than 4 GB RAM, you can't do that one. You can't do, because you have only given 4 GB RAM only. Okay, so this is the one limitation. So limitation of hardware level virtualization. This is hardware level virtualization. This is hardware level virtualization. Okay, so hardware level virtualization, like resource sharing is not possible. You can't share, no. I have given this example. If even this virtual machine 2 is not up, in that case you can use this RAM, no, to run that 5 GB RAM application, but you can't do that one because resource sharing is not possible in this case. Hardware permanently occupied by virtual machine. Yes, definitely RAM or hard disk, or that is permanently occupied with virtual machine. In this case, no other VM can use that hardware. Wastage of resources, definitely, and limited number of virtual machine you can create. See how if you I wanted to say I want to create 5 virtual machine and each virtual machine should have 4 GB RAM. How is it possible? Not possible, because I have only 16 GB RAM. I can create as many virtual machine that I can give up to 60 GB. That's it. If you want to create a 16 virtual machine and each virtual machine has a 1 GB RAM, you can do. But definitely in 1 GB you can't run any of the operating system in today's in today's technologies, because at least you must have 4 GB RAM. Even if you are using Linux, that is fine. In Linux you can run, but if you are using Windows, then definitely if you are using Windows 10, you must have at least 4 GB RAM. But in 4 GB RAM your operating system itself will load. It will not do any it will not perform any operations. It will perform, but it will be very slow. So that is that is a limitation here. You can create some amount of n number of virtual machine you cannot create. Like you cannot create 5 and each have 4 GB. It means it need 20 GB RAM, but 20 GB RAM is not there, only 60 GB RAM is there. Okay, so these are the limitations here. So now these limitations, this problems is resolved using Docker. Now you understand what is Docker here. What is virtualization? You understood what is virtualization. What is operating system? I think you understand now. Operating system is our computer operating system, like Windows, Ubuntu, Mac, CentOS, Fedora, Mint, anything. That is our operating system. What is virtualization? Virtualization is enable you to create a virtual machine. That's it. You can say in very simple one line, virtualization is used to create a virtual machine. That's it. Okay, and what is Docker? What is container? Container is like a virtual machine only. Currently you understand container is like a virtual machine. Okay, similar this virtual machine one. Okay, fine. So this is Docker. So the above problem is solved by Docker. Docker does OS level virtualization. See, now it is not doing hardware level virtualization, it is doing operating system level virtualization. What your hypervisor is doing? Your hypervisor is doing hardware level virtualization, and if you do hardware level virtualization, you are giving a particular memory permanently to a particular virtual machine, and you can't take back so that other virtual machine can use. No, you can't do that one. That is a problem here. You are wasting your resources, even that virtual machine is not in use. So in that case, Docker is coming in the picture. Now Docker does operating system level virtualization, and the virtual machine created by Docker called container, not VM, not virtual machine. Okay, so you see this diagram now, you can clearly understand what exactly is Docker here. See, this is your hardware, your machine or your computer or laptop, whatever, that has a 16 GB RAM and 1 TB hard disk or some other resources, CPU, so many are there. Okay, and on top of this hardware you have installed one operating system, Linux, Windows, Mac, any of them you have installed. But it is preferable to install Linux if you are using Docker, because Docker is developed on Linux operating system, and Docker is specifically written for Linux operating system only. Linux flavor you can use any of them, like you can use Ubuntu, you can use CentOS, Fedora, Mint, so many distributors are there, you can use any of them, whatever you want you can use. It's preferable, but yeah, definitely for this Docker is also available for Windows or Mac also. You can use on Windows or Mac also, no need to worry. But it is preferable to use Linux because it is meant for Linux only, because all the servers are running on Linux only. Okay, so here if you see on our machine, we have installed one operating system, any of operating system like Linux, Windows, Mac, you have installed, and on top of your Linux, on your operating system, you have to install Docker engine, and Docker engine will create a container, like container 1, 2, 3, 4, n number of containers you can create. Now you can see we are not giving any dedicated RAM or dedicated hardware. It has a hardware. Container 1 has a hardware and operating system, but which hardware? This has the 16 GB hard disk only. Oh, sorry, the 16 GB RAM only, or 1 TB hard disk. Now here you can see this container 1 has 1 TB hard disk and 16 GB RAM. And similar, container 2 also has a 16 GB RAM and 1 TB hard disk. We are not dividing resources now. We are doing OS level virtualization. On top of operating system, we are creating our container. So that's why this is called container now. It is not called a virtual machine. Yeah, it is treating like a virtual machine also, because each container will has operating system also. But most of the operating system it is used because of Linux only. Why? Now I have said you before, when I showed this diagram to you, I have said you one point actually. What is that one? Docker engine is preferable to use on Linux. Why? Because all the operating system, like all the distributor of Linux, like Ubuntu, CentOS, Fedora, Mint, Red Hat, all are the distributor of Linux kernel operating system. Linux is what? Linux is not an operating system. Linux is a kernel. It's a kernel only. And using that kernel, others are creating distributor are creating their own operating system. So that is the use of this Docker here. And Docker has operating system. Suppose if you have used Ubuntu, suppose on your machine, on your hardware, you have installed Ubuntu, but you want to create a container of CentOS. How it is possible? Yeah, it is possible. Or you want to create a container of Red Hat. How you can do? Yeah, you can create. Very easy, you can create. Because Red Hat, whether it is a Red Hat, whether it is in CentOS or Mint, any of them, all has the same kernel, that is a Linux. Some files are missing, so that you can download from Docker Hub. We will see what is Docker Hub also. Okay. So currently you just understand this is operating system level virtualization, and it is done on OS level virtualization. So Docker is an open source centralized platform designed to create, deploy and run the application. Okay. So here on top of our hardware, we will install operating system, any of operating system like Linux, Windows, Mac, and on top of our operating system we will install Docker engine, and Docker engine will create now container. Docker engine will create a container. So that's why this is called container, not a virtual machine. Okay, fine. But the purpose is same. It's acting like a virtual machine only, but this is in Docker it is called container. Okay, Docker engine is used to create, manage and delete the container. You can create a containers, n number of container. Like if you see the limitations here, limited number of virtual machine can be created, no, but here you can create n number of container. When you create 1000, 100, doesn't matter, because all has to use same hardware and same operating system. No problem, you can create n number of container. N number of container you can create, and resource also you can share. All will be sharing, all container. If you created 100 container, 100 container will use only this operating system, and 100 container will use this 60 GB RAM and 1 TB hard disk only. So resource sharing is possible, and number of virtual machine you can create. There is no wastage of resources, and hardware is not permanently occupied by your container, and resource sharing is also possible. So these all limitation is removed by Docker. Okay, fine. So here is the sum of the point that we have given about the Docker. What is Docker? So let's go through for them also once. So a Docker is an open source centralized platform designed to create, deploy and run the application. Docker engine used Docker engine is used to create, manage and delete the container. Docker engine is nothing but Docker only. Okay, Docker engine is nothing, it is a Docker only. Docker use container on host machine. OS, host machine is your hardware, that is a machine, host machine operating system to run the application. So Docker use container on host. So Docker use container on host machine to run the applications. It allow the applications to use the same Linux kernel as system on host computer rather than creating whole virtual machine. So if you see this diagram here, this container has the operating system that is installed on your machine, and whatever the hardware, the complete hardware this container has, it is not distributed. Okay, Docker engine can installed on any OS system, but Docker engine run natively on Linux distributor, but you can install on Windows or Mac also, it is also available now. Okay, and yeah, Linux you can download from here. Like you can see how many distributor are there for Linux. You can download the distributor like that is Ubuntu or CentOS, Fedora, Mint. So all are the Linux distributor. So you can install any of the Linux distributor. Okay, Docker is written on Go programming language, and Docker is a tool that perform OS level virtualization or operating system level virtualization. Docker first released in 2013 and developed by Solomon Hekis and Sebastian Pale. And Docker used Docker image to create container. Now what is container? We have seen what is container. Container is like a virtual machine, but the difference is it doesn't have its own operating system and hardware. It use the operating system that is installed on machine host, that same operating system it will use, and whatever the your machine hardware, that same hardware this container will use. But virtual machine will use the dedicated hardware, and each virtual machine has its own operating system. So that is the difference between container and virtual machine. Okay, so what is Docker container? A Docker container similar to virtual machine, but in Docker it is called container. It does not have its own hardware or operating system. It takes the OS and hardware from system OS only, and it is a layered file system. What does it mean of layered file system? See, in Docker in Docker files, see, Docker has a Docker file. We will explore the Docker file in our upcoming session. What is Docker file? So a Docker file has some set of instruction. We have to write our requirement in Docker file. In the Docker file, suppose we will tell what is our operating system that we wanted to use. We have to specify what are the software that I want to install this in this Docker file. In this Docker, we can specify that one. How many hardware, software, whatever software is needed for the container, we can mention in Docker file. So all the steps will be executed in the same order how you have defined it in Docker file. So that's why Docker container is a layered file system. It will execute or install the softwares in a layer forms only. That is called Docker container. It is a layered file system. It does not have its own hardware and software. Hardware or operating system. It takes the host OS hardware and operating systems. Okay, what is Docker image? Now you have seen here that one more term. Docker uses Docker image to create the container. Now what is Docker image? A Docker image is read-only template. Simply you can say it is a template. From the template you can create container. So it is like an image only. Docker image is like a read-only template that is used to create the container. Docker image is a read-only template that contain a set of instructions for creating container. Simple. Docker image is nothing but it is a read only template that has a few set of instructions for creating a container, and that can run on Docker platform only. Docker platform is nothing but Docker engine. Okay, it provide a convenient way to package up application. What is the meaning of package application? One entire application, suppose if you have to run a Java web application, so what you need? Definitely you need Java, you need a web server like Apache Tomcat, or if you are using any database persistence mechanism, then in that case you need MySQL or Oracle database also, and along with that some libraries. So all this is your requirement. So in that, if that all requirement is fulfilled, then only your application will run. So it provide a convenient way to package up the application and pre-configured server environment. So all the requirement for your application has that you can specify in your Docker image. In that template you will specify, and that template will be getting your application ready to execute. Okay, which you can use. So it provide a convenient way to package up the application and pre-configured server environment, which you can use for your own private use or share publicly with Docker users. Yeah, once you created one image, the same image you can share with the other peoples or other user, or you can say other team member, so that other will not do the same configuration. They just get that image and they will create the container. Simple. And from the container they can create a Docker file. That is a different. Okay, so that is called a Docker image, and Docker image can be published on Docker Hub also. What is Docker Hub here? So Docker Hub I will show in the next session what is Docker Hub. So Docker Hub is nothing but it is a web server where you can push or pull the images, like whatever images you have created, you can push those images to Docker Hub so that other people can pull from there directly. Simple. So this is a Docker Hub. We will see in the next session. Okay, so Docker image is executable package of a software that includes everything needed to run the application. Similar, whatever the requirement for your application, that application requirement you have to configure in Docker image. Okay, Docker image is a file used to execute code in Docker container. Docker image is a file only used to execute code in Docker container, and Docker image act as a set of instruction. It act as a set of instruction to build a Docker container like template. Docker image also act as starting point when using Docker. So Docker image is just starting point of the container. An image is comparable to snapshot in a virtual machine environment. Okay, so this is the Docker container and Docker image. Okay, Docker container is like a virtual machine only, but it has some difference. Like virtual machine has its own hardware and operating system, virtual machine has its own hardware and operating system, but container will not have its own hardware and operating system. It will take the leverage from host operating system only. Okay, and Docker image is what? It's a read-only template that contains a set of instructions to creating the containers only. Okay. Now, what are the advantages and disadvantages of Docker? Advantages are so many we have seen, but we have seen some of the advantages now. Why we moved to Docker, but along with that some other advantages also. No pre-allocation of RAM. Yeah, definitely we don't have to allocate RAM specifically for the Docker. It will be used from whatever your hardware has, same RAM it will use. Okay, continue integration efficiency. What is continue integration? This is our DevOps approach, continue integrations. We will see when we will start DevOps. So Docker enable you to build a container image and use the same image across the every step to deployment application. Once you created your Docker image, the same Docker image you can go use in development environment, because it will create your environment and everything it will do. Okay, less cost. Yeah, there is no cost. No, it's open source also. You can install, you can use. You no need to have install some other hardware or any other thing. So this is a less cost. It's a lightweight. It's very lightweight because it is a small tool only. It's applications. It can run on physical hardware or on cloud also. You can run on a physical hardware like in your local computer or local laptop or desktop you can run, or you can run it on cloud also. Okay, image of a Docker can be reused. Yeah, once you create the Docker image, the same Docker image can be used by other developer also, because once you created that image, you can push that image to Docker Hub, and from the Docker Hub other can take a pull. That's it, simple. Take very less time to create the container. Yeah, creating a virtual machine is a very heavy task and you have to really define. But if you create a Docker container, it's a very less time to create. Okay, some of the disadvantages also it has. So we have to discuss this also, because once we are discussing the advantage, we must discuss the disadvantages also. Not supported for the cross platform. What does it mean? See here, if you see this diagram, once you created suppose once you installed your Docker engine on Ubuntu operating system. Suppose, for example, this is your operating system, and operating system you are using Ubuntu. So on Ubuntu operating system you have installed Docker, and using this Docker engine you have created one container, and from this container you have created one image. So that image will execute on the other computer if and only if that computer has installed Ubuntu, or if you are using Windows. If image is created using Windows, then it will run only on Windows. If image is created on Mac, then that same image can be used in other computer if that has a Mac operating system. That is the limitation of this one. Okay, here what I am saying OS level. OS you can't say like that. If I have a Ubuntu, but in other computer I have installed CentOS, will it run? No, it cannot run, because this is a OS level configuration. Because in Ubuntu command structure is somewhat different, but in CentOS it's somewhat different. Anyway, the kernel is same for both, but still it has a limitations. It will it might run or it might not run. But if it is a different, like it is a Windows or Mac, or it will not run, because definitely you have to provide the same hardware, or same platform only. Okay, if image created on Ubuntu, it preferable to run on Ubuntu only, or if it is image is created using Windows, it is preferable to run on Windows only. Okay, Docker is not good solution for application that require rich interface. Suppose we have seen that Linux is mostly run by the commands. So Docker is also does not have a rich any UI. You have to use commands only. That's why it is saying is a not good solution for application that require rich interfaces. Okay, so that's why for server side mostly Docker is used. Okay, because server will be accessed from the browser, from the computer. That's it. Okay, difficult to manage the large container. Yeah, but we can manage, but definitely we will go this one also. If we have a large container, then what we should do? We can manage, but in generally we can say that it's a difficult to manage. We have to take some other approach to handle those containers. If we have a large containers, if 1-2 container is there, then it is okay. But if we have large containers, we have to find some way. But definitely uh, in Docker only we will find that solution. We will see. But currently here you just see it's a difficult to manage. Okay. Operating system must be same as supported the same image on other machines. Yeah, this is point same only, first point. Okay, so these all are the definitions, disadvantages of a Docker. So advantages of Docker and disadvantages of a Docker. Okay, so just revise once what is Docker, and then we will just end our session. So Docker is nothing but it's a tool that is used to create the container, and it does the operating system level virtualization. Simple. Okay, that's it. Okay, so in the next session what we will see the diagram of Docker hub. What is Docker hub, and we will see the installation of Docker. So all those we will see in our next session. So till that, bye bye and thanks for watching.